These two questions are inequalities, so we're solving systems of inequalities. We're doing this by graphing the inequality first and then shading the lines and then finding a place where the shading of the lines overlaps, which will represent the shaded region that represents both will be the solution set for these two inequalities. Without any further ado, let's go. Y is less than or equal to x plus 2. The less than or equal means that it's going to be a solid line. And we're going to go ahead and put m equals to 1 and b equals to 0, 2. 0, 2 because it's the y-intercept. And the y-intercept is going to, therefore we have something to graph. We're going to start by graphing at 2. And then we have y 1 over 1, up 1 over 1. And we have a solid line going through here. We're going to make it long and extend it right away because we have to work on the shading with the other one. Now I'm going to shade it right away because I'm going to test the point 0, 0. Well, I'm testing 0. What does that actually mean? I want to know whether 0, 0 is a solution to this inequality. So by testing it, y is less than or equal to x plus 2 is the inequality. By testing that, I'm going to put 0 in for y and 0 in for x, and which essentially is asking the question, is 0 less than 2? Well, of course it is, so that's true. And since that's a true statement, that point is part of the solution set. Therefore, I'm going to shade that to include, as you see, I'm including the point 0, 0 and everything around it. I've tested 0, 0. Could I test other points? Of course. I could test 2, 2. I could test -1, -10. I could test all kinds of points. The 1, 0, 0 just makes it easier to solve. And we got this quite quickly. And we can see that this is a true statement. Solutions to inequalities always render true statements. So now we still have another line to graph, or an inequality to graph. So we're going to go ahead and do that. And y is greater than or equal to 6x minus 3. M equals 6 over 1, and b is -3. So we have 0, -3. And in that case, our inequality, well, let's go ahead and graph that 1, 2, there we go, 0, -3. And then we're going to go up 6, 1, 2, 3, 4, 5, 6, and then over 1 right there. And these are our 2 points. And we're going to go ahead and graph that solid line because it's greater than or equal to. There's no problem there. Now, which way are we going to shade this one? It depends. We have to test points. Again, we could test any point here, we could test any point here. Why not pick one that makes it easy to choose to make it work? I'm going to do that down here. We're going to test 0, 0 again. So y is greater than or equal to 6x minus 3. Put in 0 for y. Put in 0 for x. And -3. And we get 0, question mark, is it greater than or equal to 0 minus 3? Is 0 greater than or equal to -3? Good question. And the answer is, of course it is. So that's true. When it's true, it means to include it. So the shading is going to be going this way, all the way up here, although we're not concerned about that. The place that we're concerned about, that we're interested in, is shading the area that is going to cover both sections. So even though I shade all the way up this line, right, because it represents the solutions to this inequality, the solution set, or the section that we're most interested in here, is going to be the area that has shading, both color shading, right on through both. So it's like a cross hatch, right? So I'm going to just emphasize that a little bit by shading those lines in there. And then I'm going to emphasize that with the other color. And you can see that this section right here, and I'll draw this with a different color to show the section, right along this borderline, all the way up that line, creates a triangle. And that section right there is the solution set to this system of inequalities. There it is. And you know, some people like to circle it as well. You can darken and all kinds of stuff. But what it really means, what does it mean to be a solution for a system of inequalities? It means that since the solutions for inequalities are a range of numbers that are represented by shading, well, then we're shading two different inequalities, then we've got to look at everything in the area, only in the area, that is shaded by both. So hence, we're looking at a region that works for both. Another way to look at this is to say, okay, let's look at a point out here on the graph. Well, that point, let's say up here, this is approximately, oh, I don't know, probably 2.5. That point right there is not going to be in either inequality. It's not going to work. Whereas this one's going to work for one of the inequalities, the first one. These points over here are going to work for the second inequality, but only these points in here are going to work for both inequalities. And when we say work, it means make them true. Make them a true statement. By plugging the numbers in, they'll end up being true. So that's how we solve for a system of inequalities by graphing, and I hope it helps.